This is a brief overview on using the MIL Standard 31000 TDP Option Selection Worksheet in conjunction with the Data Item Description, Contract Data Requirements List, and the Statement of Work for the acquisition of technical data.
It is probably best to select the DID first, because it needs to encompass all the data specified in the CDRL, which ultimately support the work items defined in the Statement of Work. These excerpts from MIL Standard 31000 set the boundaries for the technical data that will be delivered. It all begins with the selection of the data item description. Because the CDRL and ultimately the Statement of Work cannot extend data requirements, it is critical that the appropriate DID be selected that will not unduly restrict the delivery of the data necessary to support the needs of the program. DI SESS 80776B, Technical Data Packages, is an appropriate DID, and because it assigns a specification of the details of the data element to the MIL Standard 31000 TDP Option Selection Worksheet, it can support a very broad area of technical data elements and technical data packages. A strong argument can be made that this is the only DID necessary for technical data packages. This DID is quite liberal in its application. There are three major elements within the DID that the subject matter expert must be prepared to explain and to educate those that are not regularly involved with the specification, creation, and acquisition of the 3D model-based technical data. The first is a warning. Many, especially those that are not technical, mistakenly think it is as simple as having a statement of work that says, I want technical data in accordance with MIL Standard 31000. Unfortunately, it is much more complicated than that. The next fallacy is if you read the DID, you will find that the first paragraph states, this DID contains the format, content, and intended use of the TDP. This DID does not contain that information. MIL Standard 31000 also does not contain that information. Rather, it provides instructions how that information can be defined using the TDP Option Selection Worksheet. Further on in the DID, there is direction that the TDP elements are to be defined using guidance provided in 31000. In effect, the DID allows for almost an infinite set of data elements, and the TDP Option Selection Worksheet will tailor the requirements down to that set of data elements that will be required by the acquisition program. There are two ways that this could be accomplished. One is to specify a standard, preferably a non-government standard such as ISO 10303 STEP, ISO 14306 JT, and ISO 14739 PRC for PDF, or an industry standard such as ASME Y 14.41 for model-based definition and ASTM 52915 for additive manufacturing. The other is to specify the data elements, schema or taxonomy and ontology directly within the TDP Option Selection Worksheet. Both of these actions provide a subset of information, in effect tailoring down the DID. From the beginning, it was clear that for product model data, a higher level of granularity is required to handle the wide range of product data. This resulted in the identification of 16 technical data functional areas. As the digital engineering realm matures, the use of domain-specific data definition will increase this list. For example, the Statement of Work and Data Definition to acquire the information necessary to design and construct ship structure is completely different than the information necessary to sustain parts and assemblies and support traditional manufacturing processes, as well as additive manufacturing. For this prototype, the goal is to obtain the solid model representation that can be used to generate graphics for use in training and technical manuals and to be imported into government-owned CAD tools. This Statement of Work contains all of the work items that are necessary to develop and deliver a specific subset of product data. These items are highlighted in yellow. Product data is complicated, and due to rapidly changing capabilities of the software and continuous evolution of the model-based definition used by the OEM, there will always be a level of negotiation necessary to ensure the government and contractor can come to terms on format, but most important, content. Product model strategy, neutral format, native format, and validation report are high-level descriptions of deliverables and are highlighted in green. For product model data, the CDRL can be quite simple. The main purpose is to prescribe the delivery schedule because the details of the data will be defined using the TDP option selection worksheet. The next version of MIL Standard 31000 should seriously consider eliminating the TDP option selection worksheet and using the CDRL directly to provide the information necessary to tailor down the DID. And this is the TDP option selection worksheet. For this functional area, the data definition is relatively straightforward because other than metadata for the model, there are no additional non-graphical attributes or relationships beyond those defined in ISO 10303, Part 242. To help validate the prototype, a test case was selected that is approved for public release, relatively small, and is a part used by the Army, Air Force, and Navy, and can be used to illustrate a wide range of usage. This prototype validated that a technical data package can be generated that will provide a deliverable that contains a view that can be manipulated in 3D, contains all of the necessary configuration and control information, and also contains a 3D model in both neutral and data format. Let's take a look at a technical data package. We are still in an era where the predominant means of communicating product details is the engineering drawing. The contractual artifacts generated by this prototype will provide a 3D technical data package. The majority of 3D technical data packages currently in use are basically 2D drawings with an embedded 3D view and attached 3D files. The current generation of 3D technical data packages have static views in which the annotation has to be explicitly placed and will move with the geometry. This can be a very labor-intensive process and may require some relatively expensive add-on software for the authoring system. The 3D views provide the reader with the ability to gain greater insight into the product by taking measurements and change the perspective in real time. Associativity between the geometry and the non-graphical attributes also enables the display of information about the part through a graphical selection. But the greatest benefit of the 3D technical data package are the attached 3D data files that are used to support machine-to-machine communications. For example, the step file of the assembly that was attached to the PDF can be imported into a native CAD file for downstream applications including manufacturing and mixed reality. This was a basic overview of the creation of contractual artifacts for the acquisition of product model and other technical data